Good morning, everyone. We are from section 3, group 1. Today, we like to present about our group project. So, for my team, as Benjamin, formation CE210053, Amiru CE210027, Johan CE210148, and Hakiman AE190055. So, now I would like to explain about the question 1. Because our group is taking question 1. So for the first, we apply the nodal analysis. Then we get the equation. Then we put the value inside. And the value we need to all change to got S. So for the capacitor is 1 per C S. So we get this answer. L is just L value multiplied by S. After that, the VO, part VO, we can all change to left side, and no VO, we can change to right side. And the below one is need to be same, right? So we need to multiply by S plus 1 for the triple S. Then after that, we can simplify the 4S and S, and here all can bagi 4. Then we get the answer at here. So for part here, we need to find the A, BS plus C. So this method we call partial fraction. So we need to find the A, the S plus 1 is equal to 0. So change to 1 become S equal to 1. So we put inside the S value, then we get this answer. And for the part here, we take the S equals to S power of 2, means that all the value got S power of 2, we take outside. Then after that, we get 2A plus B. Then we put inside the A value and get this answer. For the S0 means we get the constant value. So we just A plus C only. Then equal to 13, then minus the A value. So here we get the answer and simplify, take out the 2. Then we bagi this answer and finally get the low value. And for the part here, we're using the A power of 2 plus 2AB plus B power of 2. So we get this S plus 0.6, this answer. So that for the cost, if we're using cost, the S plus 0.06, we need to same. So for the sin, the W need to same. So we just like 0.7 bagi 0.7 like this. And finally we get this answer. That's all for me. Thank you.
Okay, next for the question B, if Vs equals to 50 exponent negative t ut volt, determine the V naught t in the circuit. So we use also the KVL, but we change the value of Vs to the 50 exponent negative ut volt, which is where we get the equivalent circuit for the new Vs is 50 over S plus 1. So we insert the value for the given for the equation, and then we will get the new V naught S for the circuit is 53 plus 3S over S plus 1. V naught S is 53 plus 3S for S over okay, we will get the V naught S is 53 plus 3S over S plus 1 S squared plus 0.25 S plus 1 over 2. So we also use the partial fraction for the equation 53 plus 3S over S plus 1 S squared plus 0.25S plus 1 over 2 equals to A over S plus 1 BS plus C over 2S squared plus 0.25S plus 0.5 or 1 over 2. So for the A, we use the S plus 1, which is S is negative 1. We insert the value of S negative 1 to the equation and then we will get the value for the A is 18.18. Okay, and then next for the value B, the S squared is S power of 0, and then we insert the value to the equation and then we will get the value for B is negative 36.36. And then for the C, uh, we use the value from A 18.18 and then we minus the 53 for the equation and then we will get the value for C is 34.82. Okay, then next for the V naught S, we set the value for the A, B, and C, and then we will get the equation V naught S equals to 18.18 over S plus 1 plus negative 36.36 S plus 34.82 over 2S squared plus 0.25 plus 1. And then we equivalent the equation and then we will get the final answer for the V naught T is 18.18 exponent negative T minus 18.18 exponent negative 0.06 cos 0.7T plus 26.44 exponent negative 0.06 sin 0.7T UT volt. So next, for the last question, C, compare the result A and B. What happened when the supply voltage increase? Explain and write the conclusion from the result. So comparing the result from A and and B, it is evident that as the supply voltage V naught T increase from 10 exponent negative T UT volt to 50 exponent negative T UT volt, the output voltage V naught T also decreased from negative 9 exponent negative T UT volt to negative 45 exponent negative T UT volt. So this demonstrates a direct correlation between the supply voltage and output voltage, where an increase in the supply voltage result in a decrease in the output voltage. So the conclusion from this result is that the output voltage V naught T of the circuit is inversely proportional to the supply voltage VST. So in other words, we can say that the supply voltage we can tell that the supply voltage, when the supply voltage is increased, the output voltage will decrease. That's all from me for the manual calculation part. Thank you.
Okay, Assalamualaikum. My name is Muhammad Amirul Naim bin Muhammad Nazari. My matrix number is CE210027. Okay, now I want to present about the simulation of our circuit using MATLAB. So, firstly, this is our circuit that we create using MATLAB. So, this is control voltage source. Uh, This is inductor, capacitor, resistor and current source. So firstly we set the value of inductor for 1 Henry, and then the capacitor is 2 Farad, for resistor is 4 ohm, and the current source is 3 ampere. So then we must use this MATLAB function to put the equation from the question of the project. So firstly we put this for 10 10 exponent negative t for question A. So then we click. Before that, before I forgot, this one is for question A, and this one equation for question B. So we click run to see the waveform, and then this is the waveform for control voltage source, and then this one waveform for capacitor. So this one for question 10 exponent negative t, and then we compare the waveform this scope. So this is the waveform for 10 exponent negative t. So then next is we change the value of 10 to 50, because the question is 50 exponent. Then we click run, so we see the comparison of waveform. So we get this waveform. So that's all from me, the simulation our group. Thank you.
Assalamualaikum, my name is Johan bin Zakwan and my matrix number is CE210148, and I will continue the presentation of the slide. Is for comparison manual and MATLAB calculation. Okay, for the first one, the voltage source is equal to 10 exponent negative t. The amplitude of the waveform for manual calculation is higher than the amplitude of the waveform for simulation result. Okay, so the result of the manual and simulation differences may be caused by the internal resistance that exists inside the instrumentation, and it will cause an error between the voltage expected and voltage simulated. Okay. For the second one is voltage source equal to 50 exponent negative t, that we increase the voltage source. Okay. So the amplitude of the waveform for manual calculation is also higher than the amplitude of the waveform for simulation result. Okay. So the result of manual and simulation differences may be caused by the rise of temperature for the instrumentation when the circuit is executing. Okay. So it will cause the increase of resistance due to the resistance of conductor is directly proportional to temperature. Okay. So that's all for our group. Thank you. Assalamualaikum.